So uh, imagine using modern high-speed Wi-Fi, beamed across the globe, specifically to simulate the agonizing, screechy loading sounds of a 1980s cassette tape.
I mean, that sounds like a joke, right?
It really does, yeah. But in the new FujiNet 1.6.0 update, it's actually one of the most brilliant features on the list. So today we're taking a custom deep dive into the source material for this brand new release, which is dated May 2, 2026.
And, if you have your FujiNet plugged in, you already know it's basically the center of gravity for bringing your Atari 8-bit onto modern networks. We definitely don't need to cover the basics of what it does.
Right, exactly. The mission today is to figure out if this specific firmware update is, worth the time it actually takes to flash it to the device sitting on your desk.
Which is, I mean, that's the most practical question you can ask, right? Because when you first look at these release notes, it's just this massive wall of really technical bullet points.
Oh, yeah. Network protocols, obscure tape emulations, memory buffers. It is, frankly, overwhelming at first glance.
Yeah, but what we really need to know is if this is a must-do update for a normal user or if it's just background noise that you can ignore.
Well, if you look at the underlying mechanics, this whole update is fundamentally about resolving a very specific tension. It's about removing the friction of modern networks while preserving the difficult hardware quirks of the 80s.
I noticed that, actually, because FujiNet isn't just an Atari peripheral anymore.
Yeah.
It supports the Apple II, the Commodore, even MS-DOS machines, and the notes mention the core ecosystem gets brand new support for NFS.
Right, the network file system. Adding a whole new way to connect to modern servers is great, but I think for most of us just trying to load a game, it's FTP and SMB that cause the real daily headaches.
Oh, absolutely. So did the developers actually touch those?
They did, yeah. The FTP improvements are a perfect example of fixing that friction. If you fetch files over FTP, the directory listing and caching are significantly better now.
Oh, thank goodness, because I mean, think about what's physically happening there. You've got this vintage 6502 processor begging a remote server for a list of file names over Wi-Fi.
Yeah, and previously, the FujiNet might hand that text data over in a way that just forced the Atari to wait awkwardly. The processor would stall, the screen might pause.
Right, you just sit there staring at a frozen screen, wondering if the machine locked up or if your Wi-Fi dropped.
Exactly. So better caching means the FujiNet now holds that directory list ready in its own memory. It feeds it to the Atari smoothly, so it feels much more responsive.
That makes a lot of sense. And speaking of reducing pain, there's a change to SMB shares Windows file sharing that I saw immediately.
Oh, the URL trick.
Yeah. The notes say you can now include your username and password directly within the URL itself. I mean, have you ever tried typing a complex modern Wi-Fi password on an Atari 400 membrane keyboard?
Oh, man, it physically hurts. It
Oh,
really does.
it's awful. You have capital letters, numbers, special symbols. Nobody wants to hunt and peck their secure network credentials on that keyboard.
Totally. Being able to embed it right into the URL string means you can set it up once, maybe just from your phone, and never type it on the vintage hardware again.
By putting it in the URL, you bypass the vintage input limitations entirely. Those are the exact quality of life tweaks that make the device fade into the background.
Right, so you can just use the computer. But what about the actual bugs they squashed? I see a note here about eliminating UDP NTP errors.
I assume NTP is the network time protocol, right?
Yeah, it's how the device checks the clock.
But how does checking the clock actually affect me, like loading a piece of software?
It's essentially a domino effect. So the FujiNet checks the internet to sync its internal clock, but it was using a UDP connection to do that.
Okay, and UDP is a connectionless protocol.
Exactly. It just fires data packets out into the network and hopes they arrive. So if the time server was unresponsive, the FujiNet would struggle to complete that handshake.
Ah, so it would just keep trying and failing in the background.
Yep. And that invisible struggle was actually causing intermittent Wi-Fi scanning drops. The FujiNet would literally lose its grip on your wireless environment for, brief moments.
Wait, really? So if that drop happens during a heavy download, say you're pulling a massive multi-disk demo from a TNFS server.
The connection just flinches and the whole load fails.
Oh, wow.
Yeah. So by fixing those UDP errors, they stabilize the entire network connection during heavy data transfers. It stops the time sync from tripping up the actual data you care about.
That is a perfect under-the-hood fix. But let's look at the Atari 8-bit specific notes because this is where I got a bit confused.
Totally gets that stuff.
Yeah, they added support for PicoBoot XEX loading, which is cool, but the big headline is this new support for cassette playback, like Turbo 2000 for XLXE and QROS and EMO formats.
It's a really interesting priority, isn't it?
I just don't get it. We are using a device that communicates over modern TCP/IP, downloading files in seconds. Why spend time simulating a screechy cassette tape?
It seems totally backward if you evaluate the hardware purely on speed, but you really have to view this through the lens of historical preservation.
Okay, how so?
Well, back in the 80s and early 90s, especially in certain regions like Eastern Europe, floppy drives were just prohibitively expensive, so a huge chunk of the user base relied entirely on cassette tapes.
Right, the old Atari 1010 or 4820 tape decks. But those standard tape loading speeds were excruciatingly slow, weren't they?
Unbearably slow, like 600 bits per second. So local communities actually engineered workarounds. Clever engineers physically modified the tape decks and wrote custom loading routines to pull data off the tape much faster.
Oh, I see. And those are the custom turbo tape formats.
Right. So over time, this massive library of regional software games, local utilities, demo scene releases were distributed exclusively in these custom formats like Turbo 2000.
So if the FujiNet doesn't support those specific formats, all that history just stays locked in a drawer somewhere.
Exactly. It can't be experienced the way the original program was actually intended. So coding these obscure European formats into a modern device lets anyone preserve that software authentically.
Okay, I can actually see why people would want that. It's not about loading the game faster. You just use a standard disk image for that.
Precisely. It's about respecting the authentic architecture of how the data was stored without needing a physical, degrading, magnetic tape deck.
That's a really brilliant use of modern tech. What else is in the 8-bit specific notes for system stability? I see they restored support for Run CPM for SIO bus builds.
Yeah, so that's the emulator that lets you run the CPM operating system. And they also made a really specific improvement to the boot behavior for users who have high-speed SIO or HSI disabled.
Now, HSIO is fantastic when it works because it pushes the SIO bus way beyond what Atari shipped. But I know not every piece of software tolerates that speed.
Oh, absolutely not. Sometimes you just have to force it off to get a stubborn program to load.
So I guess this fix ensures that when you do disable HSIO, the FujiNet handles the standard slower boot sequence with better stability.
Exactly. It's basically a safety net for compatibility. You have a much more reliable fallback sequence to get your software running.
Okay, so we've covered Wi-Fi stability and obscure cassettes. Let's ground this for a minute. How does this actually translate to daily use for different types of Atari users? Like, what about people calling into BBS?
Oh, BBS users get a major win here. The R handler, which is the part of the firmware that handles modem emulation, got increased stability and better compatibility with older comms software.
So when you use a terminal program, the FujiNet acts like a vintage Hayes modem.
Right, you type the old ATDT dial commands, but instead of dialing a phone number over a landline, the FujiNet translates it into a telnet connection over the internet.
And making that handler more stable means fewer dropped connections when you're midway through reading a message board.
Yeah, the data translation is much cleaner. Now, for casual users just loading games from a TNFS server, the web UI drive selection is smoother. But I really want to talk about the power users and programmers.
Oh yeah, I saw a note about the end device that seemed highly technical. What's going on there?
It's fascinating. The end device is the network handler for the Atari. And they made it so status calls can now return the total number of bytes waiting, up to 65,535 bytes.
Okay, I'm going to need an analogy for that one.
Think of it like adding a massive waiting room to a restaurant. The 6502 processor just isn't powerful enough to handle modern network traffic. You would just buckle under the weight.
Right. It can't handle all those incoming packets on its own.
Exactly. So the FujiNet acts as the host, pulling data from the internet. Before, the Atari had to constantly ask the FujiNet, hey, is there data waiting? Which, exhausted the CPU.
Ah, and now the FujiNet just holds up to 64 kilobytes of data in the waiting room.
It tells the Atari exactly how many bytes are ready.
Yep.
It gives programmers precise control over network buffers.
So if you're writing a networked game or a weather app in Atari Basic, you know exactly what's sitting in that buffer.
You got it. It gives them the exact tools they need to build complex apps without overwhelming the vintage hardware.
That's a huge deal for new development. But does all of this only matter if you have a physical FujiNet box plugged into a real Atari?
Well, the firmware is for the hardware, but the ecosystem is definitely moving beyond it. Like, the sources note that FujiNet PC brings this exact network functionality to the Altaia emulator on Windows.
Wait, really? They added it to software emulators too.
Yeah, and the Atari 800 emulator source code supports it for Linux and Mac now. There's even a new Android app called FujiNet Go 800 with built-in FujiNet support right on your phone.
That proves the network protocol itself is becoming a standardized platform. You don't even need the physical hardware to benefit from this stuff.
Exactly. It's pretty wild.
Okay, we've hit the technical limits, the preservation angles, and the bug fixes. Let's pull this into a practical section. Let's call it, should you upgrade? What is the plain bottom line verdict for a normal user right now?
I'll lay it out plainly based on the notes. First, upgrade if you want the latest fixes. Second, upgrade if you use your FujiNet regularly.
That makes perfect sense.
Third, upgrade if you rely heavily on network features like FTP or SMB. And absolutely upgrade if a specific bug we mentioned, like the Wi-Fi dropping out, has been affecting your setup.
That sounds boring until it fixes the very thing that was annoying you. But is there any scenario where someone should hold off?
Maybe wait briefly if your current setup is mission critical, like if you're right in the middle of developing custom software and you have a fragile network stack for a project.
Right, you'd want to wait and hear early user feedback on the Atari forums first, just to be safe.
Exactly, just to be sure 1.6.0 plays nicely with your specific environment, but for almost everyone else it's highly recommended.
So if someone decides to upgrade, what is the actual process? Because it's not like the Atari has a software update button in the settings menu.
No, first you just check the official FujiNet instructions online. It takes about 5 to 10 minutes. You'll need to physically connect the device to your modern computer via USB.
And depending on the hardware revision, that's either a micro USB or a USB-C cable, right?
Yep. Just keep in mind, that USB connection is strictly for flashing the firmware. When you use it on the Atari later, it gets its power and data through the SIO port.
Right. And once it's plugged into the PC, you just use the cross-platform Python Flash tool.
Or even easier, you can use the web flasher right from a modern web browser. The only technical hurdle to watch out for is you might need to install a specific driver, the CP210X USB to UART driver, if your computer doesn't recognize the device.
That sounds highly practical and relatively painless. It's really more about refining the experience than completely overhauling it. The main takeaway I'm getting is that this firmware upgrade is worth paying attention to because the FujiNet project is still actively improving.
Yeah.
And even if you aren't a power user tracking UDP protocols or CPM emulation, you still benefit from those fixes on a daily basis.
That is the core message, yeah. The foundation just keeps getting stronger.
It's fascinating, honestly. We have this tiny device accurately simulating high-speed modems and obscure European cassettes over modern Wi-Fi, all for a computer from the early 1980s.
It really makes you think about the nature of these machines. With all of that capability handled by this one little box, what other lost, broken, or completely impossible pieces of retro hardware could eventually be resurrected just by pushing a few lines of code to that single device sitting on your desk?